Good morning and welcome back to our video series. Today we are going to talk about the light-emitting surface of a surgical lamp. This video, previously introduced when discussing about reflection technologies, aims to offer a detailed analysis about the topic. So let's start with definitions. What is light-emitting surface area? In general terms, the area of light-emitting surface coincides with the area expressed in square millimeters from which the light originates. In the specific case of a surgical lamp, the area of the lamp head from which the light actually comes out from. We could then have the case where the entire surface of the lamp head emits light, or where only elements present on the reflector emit light. Analyzing. Then this concept with reference to halogen lamps, we note how there was generally coincidence between the reflector surface and the light emitting surface. This is because conceptually the older generation lamps involved the installation of a bulb in the central part of the reflector, which precisely reflected its rays onto the parabola and finally onto the operating field. Therefore, the quality of a surgical lamp was determined solely by the size, namely the diameter of the reflector. With the introduction of LED technology, this construction paradigm is being challenged. New technical concepts then become available, and it is precisely because of the LED that it is possible to switch from the indirect reflection technology inherent in the halogen lamp to direct reflection technology. And this has a very strong impact on the light-emitting surface area. With direct reflection, in fact, it is no longer the light emitted from a single source that is projected onto a surface, but the sum of several light sources that are channeled to a point. In essence, there are several LEDs on a reflector whose light beams, the cumulative beams of these LEDs, are conveyed by a lens. It therefore becomes apparent that the surface area of emitting light at this time no longer coincides with the entirety of the reflector area, but will be limited to the area where the LEDs are placed around the perimeter of the reflector with a direct light solution. Several shadow areas are then created, i.e., areas of the reflector from which no light comes. As precisely as we saw in the video on reflection technologies, the light-emitting surface area does not depend on the lighting technology as much as on the reflection technology. Indeed, it is possible to achieve a perfect coincidence between the reflector surface area and the light-emitting surface area, even with LED technology lamps. However, we need to consider a different reflection technology. In the case of UNICA, we see how by using indirect double reflection technology, we can achieve a perfect coincidence between the light-emitting surface area and the size of the reflector. In the case of UNICA, the light emitted by LEDs circularly installed across the lamp head are reflected onto two reflective surfaces, and that allow the reflector area to coincide with the light-emitting surface. To better understand the impact of the technological choice on the light-emitting surface areas, two models are presented. Two models, both of the lamp produced by RIMSA. These models share the same reflector and are the UNICA lamp and the golden lamp. The first case, where the reflector surface area coincides with the light reflection area, and the second where this relationship is not maintained. It thus appears evident how, despite using the same reflector depending on the technology in use, I have a value of light emitting surface area equal to 100%, while in the second case this value is reduced by 45%. But why is the value of light emitting surface area so important? The light emitting surface area is crucial, I would say, because the greater this is, the less incidence an obstacle will have in getting between the light source and the operating field. Basically, the greater the area of light emission, the lower the incidence an obstacle would have on it, because the obstacle is going to close off the light component uniquely. contained in the size of my hand. In case there are black areas, that is, shadow areas from which no light comes, this area is going to further reduce the light-emitting surface area, while both lamps offer the same lighting specifications. When measuring the areas of the illuminated focus, the intensity in terms of lux or even the test values with masks, the lamps appear very different from each other, and in fact it's easily possible to perceive this difference once being used. The lamps are very different one another. Let us imagine the case of an operation and imagine that the surgeon is positioned between the dome and the surgical field, thus going to cover part of the lamp. One can easily notice how in the case of the right solution, the impact of the presence of the obstacle is greater, which means that the less light will be available on the surgical field and therefore the lower the visibility will be. The area of light-emitting surface has thus a direct correlation with the shadow suppression capacity of a surgical lamp, that is, its ability to eliminate shadows. Thank you for your attention, and I refer you to subsequent videos to further explore other concepts and issues related to the world of surgical lamps.